how do organizations navigate the incredibly fast-moving world of artificial intelligence? Deploying powerful new systems, updating existing ones, all while making absolutely sure everything stays stable, secure, and trustworthy.
Yeah, that's not just a technical question, is it? It really hits at the heart of governance, risk, operations, the whole package.
It really does. Welcome to the deep dive.
Today, we're going to immerse ourselves in a very specific, very important piece of material. Chapter 2, Part C of the ISAC, Advanced in AI Audit Official Review Manual.
Right.
This section is dedicated entirely to change management, specific to AI. It sits within that broader critical domain of AI operations.
Okay, so think of this as our guided tour. We're sort of acting as your guides, pulling back the layers on this particular part of the ISACA framework. Our mission here is really to extract the absolute core knowledge you need. What makes managing changes in AI distinct? What are the unique hurdles? And crucially, what does this all mean, whether you're an auditor, an AI practitioner, or, frankly, just someone trying to make sense of AI in the enterprise?
Exactly. And this manual material, it gives such a structured, expert-level perspective.
Yeah.
It grounds all those abstract ideas of AI governance in, practical operational considerations.
Yeah, the nitty-gritty.
It's really about understanding the how and why of managing AI changes effectively.
Okay, great. So let's dive right in then. We're starting our journey with section 2.0 at 1, and this immediately broadens our view, doesn't it? Beyond just the code and the data.
It does.
It looks at the regulatory and societal impact of AI change. Really reminds us that these AI systems don't operate in a vacuum.
Absolutely. The source material wastes no time highlighting a fundamental truth about AI today. Its rapid expansion, its pervasive adoption across, pretty much every sector now.
It's everywhere.
Right. And this isn't just a technological shift. It's societal, it's economic.
Yeah.
And that speed of evolution, that's what presents some of the biggest challenges for change management.
Why is that?
Because it means the external environment is changing just as fast, maybe even faster sometimes. The goalposts are always moving.
You said it. And the source points this out clearly. While AI development is happening at, breakneck speed, regulators globally, they're very much still trying to catch up.
That's a really critical observation.
Yeah.
The legal and regulatory landscape for AI, it's not mature. Yeah. Not at all. It's nascent. It's constantly in flux.
Like the Wild West almost.
Sort of, yeah. Think about recent things like the EU AI Act proposals or guidelines coming out on algorithmic bias, data privacy regs being updated for AI uses.
It's constant.
Exactly. This constant state of evolution means an AI system that was compliant yesterday might need, significant changes tomorrow just to meet new legal requirements. So organizations can't plan AI changes assuming a stable regulatory environment. They have to plan for uncertainty, for the likelihood of future mandates. This unpredictability, it directly impacts the whole life cycle and the change processes for AI models and applications.
So it's not just internal tech changes. Industries using AI are being constantly shaped by these external legal compliance pressures that are, like you said, literally being written in real time.
Precisely.
Keeping AI systems compliant means change management has to be incredibly agile and really plugged into those regulatory watch efforts, I guess.
You got it. And beyond regulation, there's that immense societal impact to consider, which the source specifically calls out.
Okay.
And one of the most significant, most visible areas there, the impact on the workforce.
Ah, yes. This is where it gets really complex, doesn't it? And it touches people's lives so directly. AI's potential to automate tasks, maybe even entire roles. That's a massive change factor. Any responsible organization adopting AI just has to address this.
It's a key part of the picture. The source really emphasizes that the potential for job displacement needs to be a core component of the change management analysis whenever you deploy or significantly alter an AI system.
Okay.
And it actually brings up a specific study to illustrate the nuanced reality here. It offers a valuable perspective, I think.
Which study was that?
Well, it noted that over several decades, computer-related industries were associated with eliminating up to, I think it was 1.5 million jobs in the U.S.
Right. And when you hear that number in isolation, it can sound pretty alarming. It sort of confirms those fears about automation taking over.
It certainly can. But the crucial context, highlighted by the same study and the source material here, is that over that same period, more than 19 million new jobs were created.
19 million?
Yeah. New jobs related to or enabled by those very same computer industries.
Okay, that is a powerful contrast. It really shifts the focus, doesn't it? From just job losses to workforce transformation. It doesn't diminish the hardship, obviously, for those whose specific roles are impacted, but it frames the whole challenge very differently.
Precisely. And the core insight here for change management isn't just about accounting for potential job loss. It's about proactively designing the transition pathway for the human workers.
Right.
AI change isn't just a single event where you swap out a person for a machine. It's really a catalyst for continuous learning, for skill evolution, for the emergence of totally new kinds of roles within the organization.
Like prompt engineers, AI ethicists, things we didn't even imagine a few years ago.
Exactly. AI trainers, data labelers. So
Yeah.
the source makes it clear. Organizations need to explicitly incorporate these workforce impacts. The potential displacement, yes, but also the creation of new roles and that critical need for skill transitions, for retraining. It all needs to be baked directly into their AI change management plans.
So deploying an AI system, it's not just an IT project, it's fundamentally a people project. And ignoring how workers whose jobs are affected will need to adapt, retrain, transition, that isn't just poor HR practice. The source implies it's actually a major risk to the successful and ethical adoption of AI.
Definitely. It can lead to resistance, failure to integrate the tech properly, maybe even significant reputational damage down the line.
Yeah, I can see that.
So this understanding of the external environment, the shifting regulations, the profound societal impacts, particularly on the human element, the workforce, that's precisely why AI change management cannot be treated just like deploying a patch to traditional software.
It's a different beast.
It is. Organizations must consider these broader effects, build them into planning, communication, execution. This external awareness is absolutely crucial for effective AI governance and for robust, sustainable AI operations. It really sets the stage for why AI change management needs its own tailored approach.
Okay, that gives us the essential context. Really important background. Now, let's maybe zero in on the internal realities. What happens when, despite all your careful planning, an AI system encounters an unexpected urgent problem?
Right.
Section 2.9.2 delves into handling these emergency changes in an AI system.
Okay, and let's be clear from the outset. AI systems are complex software. Just like any conventional application, they can and will encounter unexpected bugs, security vulnerabilities, performance degradation.
It's inevitable, really.
Pretty much.
Yeah.
The source makes it explicit that even the experts know AI systems can develop issues that are, frankly, not easy to resolve quickly or predictably. And this is kind of amplified by that black box nature or the emergent properties some complex models can exhibit. Sometimes it's genuinely hard to even figure out why it's misbehaving.
So when an AI system suddenly goes sideways in production, maybe it starts spitting out nonsensical outputs or performance just tanks, or worst case, it exhibits bias or makes critical errors. What are the primary strategies for addressing that emergency, according to the source?
Well, the source outlines two main strategies here. First, implementing a quick fix, often called a hot fix.
Okay.
Or second, performing a rollback to a previous known working state of the system.
A rollback?
Yeah. And it emphasizes that rollback is a critical option, especially if a quick fix isn't really feasible in the time frame you need, or if trying a quick fix carries a high risk of introducing new unintended problems. You don't want to make things worse in an emergency.
Right, makes sense. Rollback sounds like maybe the safer bet in many emergency situations. Just revert to the last stable version.
It can seem that way.
But the source notes there are unique considerations for doing that successfully with an AI system compared to, say, rolling back a database update.
Oh, there absolutely are. Rolling back an AI system isn't just deploying a previous software build. You're rolling back the state of the AI model itself.
Yeah.
And that model is intrinsically linked to the data it learned from. So the source highlights that for successful AI rollback, you need several things.
Like what?
First, and ideally, you should have considered alternative models before the emergency ever happened.
Pre-planning.
Exactly. Preparedness. Having tested backups or maybe even slightly different models ready to potentially swap in.
So a plan B, essentially. Maybe even a plan C.
Precisely. A well-defined plan B or C. Beyond that, you need a deep understanding of the specific problems that were associated with the prior model state you're rolling back to.
Okay, that's interesting. Why?
Because no model is perfect, right? Especially older ones. You need to know its known limitations, its biases, its performance quirks. Otherwise, you might be rolling back into a different, but maybe equally problematic situation without realizing it immediately.
Gotcha. You're trading one problem for another known, hopefully lesser problem.
Potentially, yes. And you also need to consider the potential problems that might have been present in the training data set of that earlier model.
Right, the data it learned from. This gets back to data lineage and provenance, doesn't it?
Precisely. If you roll back to a model version trained on a data set that you later found out had issues, maybe it was incomplete, had errors, reflected historical biases you've since tried to mitigate.
Uh-oh.
Yeah, you're reintroducing those known data problems right back into your live production system. An auditor reviewing this would absolutely scrutinize your ability to trace the provenance of the model being rolled back.
They'd want to know exactly which data version it used.
Exactly. Which version of the training data was used and what known issues were associated with that specific data snapshot and the resulting model version. That traceability is crucial for assessing the risk of the rollback itself.
Okay, that makes total sense. It's definitely a more complex decision than just picking a previous date from a drop-down menu.
Much more complex.
Now, what about those quick fixes, the hot fixes? The source points out challenges there, too. It says it's not always easily done via conventional software methods.
Indeed. A hot fix for a traditional app might just involve patching a line of code, maybe updating a config file. Simple enough, usually. With AI, the core problem might be deep within the complex, emergent behavior of the model itself. You can't just easily patch a neural network's learned weights.
No, find and replace for bad behavior.
Exactly. So the source mentions that these kinds of AI hotfixes often require significant expert effort. You need your deep learning engineers, data scientists, MLOs, specialists involved. And crucially, they can take days, sometimes even weeks, to properly diagnose, develop, test, and deploy safely, even when everyone's under pressure.
Days or weeks, that's a stark reality for something called an emergency fix. That's a long time for a critical system to be broken or performing poorly.
It is. And that timeline really underscores the need for robust emergency procedures and those fallback options we talked about, like rollback or alternative models.
Yeah.
The source does mention a fascinating potential approach for a high fix, though, when the core model is the issue. It talks about shielding.
Shielding.
Yeah, shielding the AI system's input processing and output post-processing from the problematic internal model.
Shielding. Okay, can you elaborate on that? What does that actually look like in practice for an AI system?
Well, think of it like building an intelligent buffer layer around the core AI model.
Okay.
So if the model is suddenly misclassifying inputs or producing biased results or maybe outputting data in the wrong format because of some internal flaw,
Right.
this shielding layer, which would likely be implemented in the surrounding application code or the MLOps infrastructure,
Great.
so outside the AI model itself, could intercept problematic inputs before they even reach the model.
Okay, filtering the input.
Or it could intercept the flawed outputs after they leave the model, but before they reach the user or whatever downstream system relies on them.
So cleaning up the output, it's a way to try and correct or filter the data flow to or from the faulty model without actually having to retrain or rebuild the model itself in the heat of the emergency.
Exactly that. For instance, if the model suddenly starts adding a weird, spurious tag to all its outputs, the shielding layer could be quickly updated to just detect and remove that specific tag.
Like a quick patch on the outside?
Sort of. Or if a particular type of input is causing the model to crash, maybe the layer could identify and divert those inputs or pre-process them in a way the model can handle. It's definitely a temporary measure, right? A sophisticated Band-Aid, really.
Okay.
Designed to mitigate the symptoms of the AI model's problem, while a more permanent fix, like retraining the model or developing a new version, is worked on in the background.
That makes sense.
It requires careful implementation, careful monitoring, of course, but it does offer a potential path to at least partial restoration of service, much quicker than a full model replacement might take.
That's a really practical insight into emergency response for AI. Very useful. Now, regardless of whether an organization opts for a quick fix, like shielding, or a full rollback, the source is absolutely clear on one non-negotiable requirement, even under emergency pressure.
Let me guess. Review and approval.
You got it. The need for review and approval.
Absolutely critical. Emergency doesn't mean throwing governance out the window. The source stresses that their relevant stakeholders need to be involved.
Who would that typically include?
Well, not just the technical teams. It could be business owners, legal, compliance folks, risk management, potentially representatives from areas directly affected by the AI's malfunction. They all need to be part of the decision-making for any emergency changes proposed for an AI system.
And they need to actually review and approve the proposals.
Yes. review and approve all emergency change management proposals.
And importantly, the source says organizations should leverage their existing change management approval protocols where possible, right? Adapting them for the AI context and urgency.
Exactly. It's not about creating entirely new bureaucracy just for AI emergencies. It's about extending those established governance frameworks to encompass the unique risks and characteristics of AI.
So you need a predefined, documented process for emergencies.
Definitely.
Yeah.
Including who needs to be notified immediately, who has the final approval authority, and maybe even the criteria for deciding between attempting a hot fix versus just going straight for a rollback.
And an auditor would look for evidence of this process.
Absolutely. They'd look for evidence that this emergency process exists, that people understand it, and crucially, that it was actually followed during a real incident. You definitely don't want chaos compounding the emergency just because it's urgent. Maintaining that structured review and approval, even if it's expedited, is just essential for accountability and minimizing downstream risks.
Okay, really good points. So we've covered the external pressures shaping AI change and the internal challenges of handling those unexpected emergencies. This leads us very naturally to the foundational discipline required to manage AI systems day to day and really to prepare for changes effectively.
Yeah, configuration management for AI systems. That's the focus of the next section, 2.10.3.
Right, and this is where, as you said, prevention meets preparation.
It is. And the source makes it super clear right away. Configuration management for AI systems looks fundamentally different from managing the configuration of, say, a traditional IT server or a network device or even a standard software application.
Why a difference?
Because an AI system isn't just a single piece of software. It's really a composite. It's made up of highly interdependent components, and all of them need rigorous tracking and versioning.
Okay, so what are these key components that the source emphasizes organizations must track as part of their AI configuration management?
The source explicitly lists the crucial items that make up the configuration of an AI system. So first and foremost, the data sets used.
The data itself.
Yes. And this means both the training data sets used to actually build the model and the production or inference data sets that the model processes in real time. You need to know their versions, their sources, maybe even snapshots of their contents at specific points in time.
So it's not enough to just say, we use dataset X. You need to know, like, we used version 2.1 of dataset X sourced from system Y containing data up to date Z. That level of detail.
Exactly that level of detail. Data provenance is absolutely paramount. Second, you need to track the AI models themselves.
The models, okay.
This means the model architecture, the specific code defining it, the trained weights and parameters, and importantly, specific versions of the model. Just like software, models evolve. They get retrained, fine-tuned, maybe replaced entirely. Knowing exactly which model version is running in production at any given moment is completely non-negotiable.
And I'm guessing linking that model version back to the specific dataset version it was trained on is also critical here.
Oh, absolutely fundamental. That linkage is key. The third key item is the surrounding environment and code.
Okay, what falls under that?
That includes the inference code that actually loads and runs the model, the pre-processing and post-processing pipelines we talked about.
Right, the data handling.
Yeah, the libraries and frameworks used like TensorFlow, PyTorch, scikit-learn, whatever it is, and their versions, and even the hardware or infrastructure configuration where the model is deployed. All of these things together constitute the operational configuration of the AI system.
Wow, okay, so the configuration of an AI system isn't static at all. It's this dynamic interplay of data, the model itself, and all the surrounding code and infrastructure.
Precisely. And the central goal of meticulously tracking all these key items, datasets, models, their versions, the processing pipelines, and the environment, is to monitor them constantly for any deviations from established standards or, expected validated states.
And why is that monitoring so critical?
Because, as the source really emphasizes, AI systems and models are incredibly sensitive to changes in their configuration, sometimes in ways you wouldn't expect.
Sensitive how? What kind of configuration changes, maybe even seemingly small ones, can have a big, perhaps unexpected impact?
This is a really key point where AI differs significantly from traditional applications. The source highlights that configuration changes in the data preprocessing pipelines.
So the steps taken to clean, transform, format the data before it hits the model.
Yes, exactly. Both during training and during production runtime. Changes there, or even subtle changes in the data sets themselves over time, can have a significant, sometimes quite dramatic impact on the AI model's performance, its accuracy, and the outcomes it produces.
Can you give a concrete example? I think the source mentions one about data processing that illustrates this sensitivity.
Yes, it does. It provides a very specific and, I think, insightful example related to natural language processing, NLP, though the principle really applies more broadly to other data types too.
Okay.
It states that even subtle changes in the tokenization framework used to process text data can have a major effect on the AI model's behavior.
Tokenization. Right, that's the process of breaking down raw text into discrete units, tokens, that the model can actually understand, like splitting sentences into words or maybe breaking words into subword units.
Exactly that.
Yeah.
And if you use one tokenization algorithm or configuration when
Hmm.
you're training the model, maybe it treats hyphens a certain way or splits contractions differently.
Okay.
And then, when the model is running live in production, you use a slightly different version or configuration of that same tokenization process. Well, the model is now receiving input that looks fundamentally different from what it learned on during training.
Ah, I see. So, like, the word walk-in might be seen as one token walk-in during training, but then maybe as two tokens walk-in in during production if the tokenizer changed slightly.
Precisely. Or think about a word like cannot. Does your tokenizer see that as cannot, one token, or can plus not, two tokens?
Right.
If the model was trained exclusively on data where cannot was always treated as two tokens, and then you switch to a tokenizer in production that treats it as one token, the model might suddenly fail to correctly interpret negation in sentences.
Wow.
And this seemingly minor change in data preprocessing can lead to significant errors, maybe nonsensical outputs, or just a drastic drop in performance. And critically, this can happen without any change to the core model code itself.
That really highlights the hidden complexities, doesn't it? It sounds like ensuring absolute consistency in how data is prepared and presented to the model,
Yeah.
all the way from training through production, is just paramount.
It really, really is.
Yeah.
The source strongly reinforces this need for consistency. It specifically states that the same tokenization framework, the same configuration, the same version used during training absolutely must be used during production or inference.
No wiggle room.
Pretty much. Any drift in that pre-processing pipeline or even changes in the characteristics of the input data itself is a configuration change that needs to be managed just as carefully as a deliberate model update.
So careful and detailed configuration management, tracking these specific components like datasets, models, versions, processing pipelines, the environment, and ensuring that consistency, especially in data handling, it's absolutely essential.
Yes.
It's foundational to ensuring the AI system operates reliably, predictably, and continues to deliver the intended, validated outcomes.
Fundamentally. Without robust configuration management that's tailored to AI's unique, data-centric, multi-component nature, any changes, whether they're planned updates or those emergency fixes we discussed, are far more likely to introduce instability, errors, bias, performance degradation, you name it.
It's the underpinning discipline.
It really is. It's the discipline that underlies trustworthy AI operations.
Yeah.
And an auditor assessing AI controls would certainly look for evidence of a mature configuration management system, one capable of tracking these AI-specific components and, crucially, their lineage.
Okay, well, that brings us to the end of our deep dive into this really critical section of the ISA manual. We've unpacked Chapter 2, Part C, focusing squarely on change management specific to AI.
We have. We started by looking at that essential external context, the rapid AI evolution creating that shifting regulatory landscape, and those profound, unavoidable societal impacts, particularly on the workforce. That really highlighted why AI change management is fundamentally different and needs that broader perspective.
Right. Then we moved into the internal operational realities. We explored the unique challenges of handling unexpected emergencies in AI systems, discussing strategies like quick fixes and rollbacks, and detailing the specific, often complex considerations for each. Things like understanding prior model issues, data provenance, and that interesting concept of shielding.
And finally, we examined the foundational requirement of configuration management specifically for AI systems. We identified those key items that absolutely must be tracked: data sets, models, versions, processing pipelines, and emphasized the critical sensitivity of AI to changes in data configuration and the absolute necessity of maintaining consistency from training all the way through production.
So for anyone listening who's involved in AI operations, governance, risk management, or auditing, understanding these distinct aspects of AI change management isn't just theoretical knowledge, is it?
Not at all.
It's crucial for building resilient AI systems, for proactively managing the inherent risks, ensuring the AI stays effective, reliable, trustworthy, really for navigating the complexities of deploying and maintaining AI in the real world.
Yeah, it really requires adapting those established IT change practices we're familiar with, and also developing new ones that explicitly account for the dynamic, data-dependent, and often less transparent nature of AI models. It's an evolving discipline itself.
Exactly. And it leaves us with perhaps the most important question to ponder as you reflect on all this information. Considering how quickly AI technology continues to evolve, constantly presenting novel challenges and capabilities, how can organizations build change management processes that are not only robust enough to handle the complexities we've discussed today, but also agile and forward-thinking enough to adapt to entirely new types of changes, risks, and opportunities that, frankly, we can't even fully predict yet?
That's the million-dollar question, isn't it? It really underscores the continuous learning required
Yeah.
in this age of AI.
Indeed, it does. Well, that's all for this deep dive. Thanks for joining us.